One of the most important things that you can do in the data world is interpret the meaning of the results. And every now and then, something really weird happens with data. A good example of this is known as Simpson's paradox, or a paradox that happens when you have aggregated and disaggregated data. This is best known from a 1970s lawsuit on gender discrimination at the University of California, Berkeley for graduate admissions, where it was found that female applicants had a lower overall acceptance rate than male applicants. Well, the university decided we need to fix this problem, and so they went and looked at 48 different graduate programs to find out what was going on. And what they found was really weird. Only a small number of programs showed a preference for male applicants, and an equal number of programs showed a preference for female applicants, and the majority showed no overall difference. And the idea is, what happened? It was there when we were looking at everything, but it disappeared when we were looking at individual cases. This is a statistical paradox, and what happens is that the female applicants were generally applying to programs that were smaller and more selective, so they accepted a smaller number of candidates, whereas the male applicants were generally applying to programs that were larger and had higher acceptance rates. When you combine those things, you can get an overall effective discrimination even when it's not there at the individual level. A similar thing shows up, for instance, when you're comparing states. Compare Utah to the rest of the United States. It's different in so many different ways. And people sometimes talk about it being a Utah magical mojo that makes Utah operate in particular ways. But really what a lot of it is the fact that, for instance, we have a lot of kids in Utah. And so anything that's more common among kids is going to be more common in Utah. There are other demographic distinctions that can explain what's going on here, and you have to watch out for the differences. If you're comparing different states like California, which is larger than a number of countries in the world, and you're comparing to, say, Montana, which is the size of some cities, you're going to find these statistical artifacts. If you combine them, you'll find overall patterns that you don't see when you take them apart. Now, going back to this case of gender discrimination, a lot of people look at it and say, we disaggregated it, we found that there was not a reliable pattern of gender discrimination, problem solved. Actually, no, not problem solved. The next question is, why were the programs that women were going to apply to smaller, and why did they have lower acceptance rates? Was there gender discrimination in the funding and the staffing of the programs? And so you haven't answered the question by finding a paradox, you simply push it to the next level. And that's why people with a background in the humanities, the liberal arts, and the social sciences, who are specifically trained in looking at the questions behind the questions, are better suited to answer things like Simpson's paradox. If you want to learn more about how people with backgrounds in the humanities, social sciences, and liberal arts are able to interpret data as a human construct, watch our next video.